For centuries, scholars believed they understood the story of the Caribbean's first people, relying on pottery fragments, stone tools, and centuries-old colonial accounts to piece together their history. But beneath the humid soils of islands like Cuba, Puerto Rico, and Hispaniola lay a hidden truth that would shatter those long-held assumptions and reveal a far more complex and tragic tale of human migration, replacement, and survival. The mystery centered on a fundamental question that had haunted archaeologists for generations. Where did the Caribbean's original islanders come from, and what happened to them when new waves of people arrived? For decades, the evidence seemed clear enough, with distinct archaeological periods marked by dramatic shifts in tools and pottery styles, suggesting different groups of people arriving at different times. Yet there was something deeply unsettling about the narrative, something that didn't quite add up, and the answer to this ancient riddle would remain locked away until scientists could peer directly into the genetic code of the dead themselves. The Caribbean presented an almost impossible challenge for anyone seeking to extract ancient DNA from human remains. The region's relentless heat and suffocating humidity, combined with acidic tropical soils, work like a biological demolition crew, rapidly breaking down organic matter and destroying the fragile strands of DNA that might otherwise survive for thousands of years in colder climates. For generations, this environmental reality meant that the Caribbean's ancient people would remain voiceless, their genetic secrets seemingly lost forever to the ravages of time and decomposition. But hidden within the human skull lies a tiny fortress of bone, a dense structure protecting the inner ear known as the Petrous bone. And this remarkably resilient anatomical feature would become the hero of this story, preserving genetic material where all other tissues had long since turned to dust. In the early 21st century, archaeologist William Keegan had spent more than 40 years excavating Caribbean sites, meticulously cataloging pottery shards and stone tools, all while wrestling with questions that seemed impossible to answer definitively. His decades of fieldwork had revealed two distinct cultural periods: the Archaic Age, beginning roughly 6,000 years ago, characterized by stone tool users who left no pottery behind, and the Ceramic Age, starting around 2,500 to 3,000 years ago, marked by sophisticated pottery-making farmers. The archaeological records showed that Ceramic Age pottery underwent at least 5 dramatic style changes over 2,000 years, with ornate red vessels decorated with white painted designs giving way to simple buff-colored pots, then to vessels punctuated with tiny dots and incisions, and finally to sculptured animal faces that likely served as handles. Many archaeologists interpreted these radical artistic shifts as evidence of new waves of migrants flooding into the Caribbean from the mainland, bringing fresh ideas and replacing or absorbing earlier populations. In 2020, geneticist David Reich at Harvard Medical School assembled an international team that would finally put these archaeological debates to rest through the largest study of ancient human DNA ever conducted in the Americas. Reich's laboratory had developed cutting-edge techniques for extracting and sequencing degraded DNA from tropical environments, methods that could coax genetic information from the Petrous bone even when all other skeletal elements had failed. The team analyzed the complete genomes of 174 individuals who had lived in the Caribbean between 400 and 3,100 years ago, a dataset that represented more ancient DNA from this region than all previous studies combined. The extraction process was painstakingly slow, with researchers drilling into the Petrous bone to access the protected inner chambers where DNA fragments might still cling to life after millennia of environmental assault. The results were staggering in their clarity and profoundly disturbing in their implications. The genetic data revealed that the Caribbean's first inhabitants, those Archaic Age stone tool users who arrived around 6,000 years ago, were indeed a distinct population most closely related to groups from Central or South America, though their exact origin remained frustratingly unclear. Then, beginning around 2,500 to 3,000 years ago, a completely different group of people related to the Arawak speakers of northeast South America migrated northward from the Orinoco River basin in Venezuela, island hopping through the Lesser Antilles until they reached Puerto Rico and eventually pushed westward across the entire Caribbean archipelago. What happened next was nothing short of a prehistoric catastrophe. The genetic evidence showed that these Ceramic Age newcomers almost entirely replaced the existing archaic populations, with the original islanders vanishing from the genetic record across nearly every island except for a small holdout community in western Cuba that somehow persisted until European arrival. The scale of this population replacement was unprecedented and deeply mysterious. Among the 174 ancient individuals analyzed, only 3 showed any evidence of mixed ancestry between Archaic and Ceramic Age people, revealing that intermarriage between these two groups was extraordinarily rare despite living in close proximity for potentially hundreds of years. Whether this near-total replacement resulted from violence, disease, competition for resources, or some combination of factors remains unknown, but the genetic data left no room for doubt about the outcome. The finding forced Keegan and his fellow archaeologists to confront an uncomfortable truth. One of the Caribbean's first peoples had been almost completely erased from existence long before Columbus ever set sail, their genetic legacy surviving only as trace elements in modern populations and as a mysterious holdout in Cuba. But the study revealed an even more surprising twist that would overturn another long-standing archaeological assumption. Those 5 dramatic shifts in pottery styles during the Ceramic Age, which many scholars had interpreted as evidence of new migrations bringing fresh populations to the islands, turned out to be nothing of the sort. The DNA showed remarkable genetic continuity across all these stylistic changes, proving that the same population was responsible for developing these wildly different artistic traditions over 2,000 years. This was not a story of pots carried by new people, but rather a testament to the extraordinary creativity and cultural dynamism of a single group of islanders who innovated and reinvented their artistic traditions generation after generation. Postdoctoral researcher Kendra Sirac, working in Reich's laboratory, helped uncover another startling dimension of Caribbean life that spoke to the island's deep interconnectedness. By analyzing segments of shared DNA, she and her colleagues identified 19 pairs of genetic cousins living on completely different islands, individuals separated by hundreds of miles of open ocean, who nonetheless shared enough DNA to confirm they were fairly close relatives. In the most striking example, one man was buried in the Bahamas, while his genetic cousin was laid to rest approximately 600 miles away in the Dominican Republic, a discovery that suggested Caribbean people were far more mobile and interconnected than anyone had imagined. This high frequency of cousin pairs within a relatively small sample revealed something else profound and troubling about the pre-contact Caribbean. Working with postdoctoral researcher Harold Ringbauer, Reich's team developed a revolutionary new genetic technique that could estimate ancient population sizes by measuring how closely related randomly sampled individuals were to each other. The more genetic cousins found in a random sample, the smaller the source population must have been, since larger populations would rarely produce such close familial connections among randomly chosen individuals. When they applied this method to the Caribbean data, the results were shocking. Somewhere between 10,000 and 50,000 people were living on the combined islands of Hispaniola and Puerto Rico in the centuries before European arrival. This number stood in stark contrast to the accounts of Christopher Columbus, who had reported populations in the hundreds of thousands or even exceeding 1 million people to impress his royal patrons. 16th century historian Bartolomé de las Casas later claimed 3 million indigenous people had inhabited the region before European colonization decimated them through enslavement, disease, and systematic violence. While the Dao genetic data revealed these specific numbers were exaggerations, Reich and his colleagues emphasized that this finding should not diminish the profound tragedy of what occurred after 1492. The cultural erasure that followed European contact remains one of history's first genocides, regardless of whether tens of thousands or millions of people were destroyed. Today, modern Caribbean populations carry between 4 and 14% indigenous ancestry. Genetic traces that confirm the ancient islanders' DNA has persisted continuously in the region for thousands of years, mixed with European and African ancestry from later migrations. For Keegan, collaborating with geneticists gave him the ability to prove some hypotheses he had argued for decades while completely overturning others. But more importantly, it demonstrated just how essential cultural forces are in shaping human societies beyond simple genetic inheritance. The Petrous bone, that tiny fortress protecting the inner ear, had finally given voice to people silenced by time and catastrophe. Their genetic legacy tells a story far more complex than anyone imagined, of multiple migrations separated by thousands of years, of one population mysteriously replacing another, of remarkable artistic innovation across centuries, and of highly mobile island societies connected by intricate family networks spanning vast oceanic distances. If you found this investigation compelling, make sure to like, subscribe, and share your thoughts in the comments below, and join us next time as we continue uncovering the hidden genetic mysteries that are rewriting human history.